So this textbook has different versions of the code per chapter. In the code, what I'm explaining right now, it is very close to chapter 1. The code which is very close to chapter 2, it will be in the next lesson. The code in chapter 1 is not using view model, but code in chapter 2 is using view model. So today's example for the list is without view model, but it will be in the next lesson. I decided to split it because state is more complicated if you have a scrollable list or like a long list of items, because this list is selectable in the example of the code. And when it is selectable, you have state per item. It's not state for entire piece. Also, you have state per entire piece. But in addition, you have state per item. So it is more complicated internally. So I decided that to explain without list and now later with list. So I'm going to GitHub. So it is not original. It is just small changes. Code, copy it, and I will clone it. So get from version control, Control V, RestaurantsApp. You can always edit name of this folder. It's up to you. It doesn't have to be call it as it is on GitHub. All right, and let's clone it and see. Trust project. Hopefully it will work, because I spent several hours yesterday to make it work. Here it is. So in main, I created branch chapter 1. In chapter 2 will be in chapter 2 branch, but it's not posted. I'm still working on that one. And I will keep adding branches per chapter. So this is current approach. Maybe later I will just create another repository for chapter 3, whatever. But next time it will be chapter 2. In Git, you will see that it is the same commit, so it was only one commit for main and chapter 1. Essentially, because I didn't change much of the code, plus committing something that is broken, it's not really a good idea, in my opinion. So let's run it and see what it's doing first. So this project has different complexity. It is simpler because it doesn't have any user inputs, no ready button, no checkboxes, just as display data. So in terms of no user input, it is simpler. But complexity comes from the fact that you have a long list. Animation like this, you see it's kind of bouncy. It comes by default, so you don't have to create this bouncy thing, or you can customize it, but it's part of the same. Okay. So since it does not have any user input, and technically it is just displaying data which is given, they didn't need to maintain any state because state doesn't change. So how it behaves? It has some hard-coded data, and when activity starts, it displays the data, hard-coded. Okay. If we rotate the screen, activity will be destroyed, created again, it will display the same data. Because we do not change it, so we don't need to maintain any kind of state if data is not changeable. This is why it is simpler than tip calculator in the previous version in the previous week. Because in this case, we don't have to maintain any kind of state. Because there's nothing is changing in this program, essentially. Okay? So let's see what we have. We have main activity, restaurant, and restaurant screen. Okay. So remember that in my program, tip calculator, I had the screen inside of main activity. So I had the function tip calculator screen. Right? If we open main activity, you will see tip calculator screen. It is the most outside function, and no, not the most. It is one step below, and it was a function, it was up that was inserted into main activity. But bottom line, my composables were all inside of main activity. What would happen if we have a lot of composables? Essentially, we will end up with a huge file, which is not a good idea. Especially, it's not a good idea if we have a lot of screens, and a lot of screens would be inside of the same file, which is a nasty approach. So they, who wrote this code, envisioned future and separated screen function outside from main activity. So I didn't do this step in tip calculator. I will do it at the next step when we'll have more than one screen. I will separate it. But the difference is in main activity. You see, this is composable function that they just copy pasted into another file, and it lives in separate file. And obviously, you need to import this file. Okay. No, you don't, because it is in the same package, so it's easy. But if you create package screens, so in apps we create package screens to keep screens in separate package as organized. You will have to import. In this case, you don't, because it's all in the same folder. So this restaurant screen is just composable, and we have other composables that are inside of it. Okay. So what is restaurant? Please notice that when you don't have a KT, it means this file contains only one class. When you have a KT, it is not class or class and something, class and functions. So in this case, main activity is just one class, so this is why it doesn't have KT. If you compare this to main activity class in tip calculator, it will be main activity.kt, because I had composable functions outside of the class. So this is how Android Studio is telling you that you have one class or one class and something. In this case, it is when you don't have a class or just some functions, it comes with KT, you see. In restaurant, you have some class and something else. So this is why it is KT. It is class and something else. So let's see what is restaurant KT. They define it restaurant data piece, okay, which is ID, title, and description. Then they created just a list by brute force, public, so it is readable from outside. So essentially, they created global variable. And this is global, so they just because it is global variable, they can read it from activity. Okay. So restaurants list of, and they call it constructor many times. So dummy restaurants, and since it's a constant val, it's not changeable. And it is fine for this example because it is just displaying static data. And it doesn't have any state because it's just displaying static data, nothing is changing. Okay? So this is where data is coming from. It is just hard-coded. So in main activity, also not interesting, it has theme and call of composable function, similarly to tip calculator, theme and call of composable function. But in tip calculator, I just had it in the same file, but they did it slightly smarter. They moved it to a separate file for better organization. All right? So what is inside of screen? It is supposed to be one screen. So they have a previews. They have one preview. Okay. So this fits the screen. Okay. And this is why running. So this preview is not the same as this one. We learned about it. So I want to close preview so I have more space on the screen. All right. So what is inside of restaurant screen? I have a lazy column and nothing else. Right? So screen is one composable function, call it lazy column. Why it is lazy? It is lazy because it is processing items only that are supposed to show up on the screen. It is ignoring other things. It doesn't do much of the stuff ahead of the time. If it were a regular column, and if the list is long, it will be a lot of memory wasted, essentially. So it is doing processing for the stuff on the screen and a little bit outside, so when you scroll, it is smooth. So this is lazy column. They added content padding to the lazy column, and content padding it is outside, right? Vertical and horizontal, vertical and horizontal, 8 dp, and items. When you create lazy column, you can add items as many times as you like. Item, it is just one. Items, it is something iteratable that is calling composable functions. So technically, a lazy column can contain mixed stuff, like you have a header, some list, another header, another list, another header or footer. So you can combine items and item to create lazy column. So in this case, they decided to be simple. So they have iteratable item, which is list of. You saw that dummy restaurants, it's list of restaurants. And items, it's a function that receives first argument, it's a list, and second argument, it's lambda function, to be called on every element of the list. Okay. Remember that we can take lambda function outside of, if it is last parameter, we can take it outside. So it is a lambda function to be called on every element of the list. So this will be restaurant, it's one of the list. So it will call restaurant item, another composable function, for every item on the list. So type of the item is restaurant. So this is how lazy column works for just one list. You can add item above, item below, another item, so it doesn't have to be one piece inside of lambda function. It doesn't have to be one piece here. It can be a combination of item and items. Okay? So next, we have a restaurant item, this one, and as you see, it's a cart. So it's not new. You were familiar with cart before. And cart, what I mentioned, it's not compatible between material design 2 and 3, and this is 3. So I changed elevation to cart defaults, cart elevation, this one. This is a small difference. In previous version, elevation was assigned as just 4 dp. Now they don't have an option to assign it directly, so you have to create wrap around it. So that was the reason why its card is not compatible. And then we change padding. It is inside of the card, so these pieces are not starting from edges. So we have a wrap around them, ADP. And content of the card is raw. So we have one item and another item. What is interesting, and we didn't see before, we have weight. So this row contains two items, restaurant icon, it is another call, and restaurant details, another call. These functions have modifier weight. Weight, it is proportions how much space it takes. If it is row, it is horizontally, how much space. If it is, you can have it for column as well. So this is 15% and 85%. Okay. So that's how much it is stretching to occupy space. This restaurant icon, it is this part. It is containing just image. And image is reference to icon. So it is icons fill it place. It is coming from library. Fill it place, so it is name of this. So it is material design comes with built-in items and this icons, and that's one of them. When you create image, it forces you to provide description. It is for screen readers. Modifier is optional, but they created extra padding around it, around this image. All right. So this is for icon. This it contains of two pieces. You see kind of header and kind of description, right? So it is column. So details, restaurant details, it's a column of two pieces. Font is different. In tip calculator, I use a different approach. I use it brute force. So I change it font size directly. What they use predefined theme. They didn't change theme. They use material theme and use it reference to it. So it's not reference to font, it is reference to style. And material theme comes with headline small font. So it is referring to small font for headline. Whatever is there, we can redefine it. If we edit theme, we can redefine size of it if we don't like it. So it's a little bit nicer approach than brute force coding of font. We can create, so for future iterations of tip calculator, when we learn how to define style, we will refer to this but redefine. But it is hard-coded now, not redefine it. Okay. And for description below, it is text description. It takes two parameters, description and title and description. It is large font. So some font defined as body large. It is large font for body. So this is for restaurant details. So it is this column. And this is it. So it is relatively short. Okay? But it looks like relatively short because we already know a lot, right? But of course, it has to be not insanely huge because it is first chapter of the textbook. Right?